Okay, so today we're looking at just another short one, looking at just a few different sorts of forces and things. So, first of all, something we need to look at here is mass and weight. So, in physics science, mass and weight mean something different than everyday language. So, in physics, mass is a measure of how much material you've got. Here's the missing word. In an object. Alright, so you, for example, if you go, from one place to another, the amount of you stays the same. If you went to the moon, the amount of you would stay the same. So that's what we would call mass, and that, of course, that's measured in kilograms. Now, everyday language has this next one that's different to what in physics that we do. So in physics, weight is the pull of gravity. Okay, everyday language, we talk about it as different, but weight is the pull of gravity, so it's a force, and it's in Newton, of course. All right, so what it depends then on is how strong, or the strength of gravity. Okay, so if you went to the moon, unless you lost an arm or a leg on the way, your mass would be the same, but your weight would be different because the strength of gravity on the moon is different. Alright, so pull's the missing word there. And so in the next one, mass and weight are not the same. Alright, so mass and weight are not the same. And that's the missing word there. Alright, so they are, however, related. Okay, because as we said here, weight is the strength of gravity. The strength of gravity what? The strength of gravity pulling on you, and you have mass. So weight, the weight force, equals the mass times gravity. Or if I'm going to be more specific, it'd be times the gravitational field strength. Is what it would be. And so we write that in shorthand, and this is the last bit in the notes, is where weight equals mg. Now it is a vector, and it's in the same direction as the gravitational field strength, which is towards the centre of the Earth if we're standing on the Earth. All right, so that's mass and weight. So remember, mass is the amount of material in something, and weight is the force of gravity, the pull of gravity. All right, so that's in science. Everyday language, forget about everyday language, it's different. All right, so some other types of force. First one we're going to look at is friction. And friction is a force, and it opposes, so it's a force opposing motion. Alright, so air resistance, all sorts of things like that are friction. Alright, so there's some examples there. If you drag a table across the floor, it's difficult, or it can be if the floor's covered in carpet particularly, because there's a lot of friction. Car in the air is another one. Alright, tension. Alright, tension again is a force, it's a pulling force. And what it's trying to do is to, and this is the missing words, stretch or elongate an object. Alright, so along strings, wires, things like that would be tension forces. Alright, the next one in your notes I've already mentioned, we've done it again, weight. Don't know why I've got that twice, but anyway. Alright, so it's a force by which mass is attracted to the Earth or any other planet or whatever. And gravitational field strength, so weight is your mass times the gravitational field strength. Here on Earth, the gravitational field strength is 9.8 Newton for every kilogram. So if you are 1 kilogram, you experience gravitational pull of 9.8 newtons. If you are 100 kilograms, you feel a gravitational pull of 980 newtons. Alright, and then the last force we are looking at is what's known as the reaction force. So now you're sitting down on the chair, there is a reaction force holding you up. So you're sitting on the chair. So here's the chair, bang, beautiful. Here's you, let's see, you can be blue today. So there's you sitting on the chair, having a good old time doing your physics. And so you have a weight force trying to drag you down. Now, the fact that you don't fall down means something's holding you up. And what's holding you up is the force of the chair on you. So you probably can feel that in the bum if you think about it. And so your weight force is down, and then so the reaction, which is chair on you. Alright, so in the notes there, when the body sits on a surface, there is a force acting upwards to prevent it falling downwards. It's called the reaction force. Alright, and there's a little diagram, something similar to that. Alright, no examples on this. So problem set number 12 in the text. If there's anything there you're not sure of, make sure you ask. Also, there's some videos on the lesson there for you to have a bit of a look at.